Hi everyone. So today we are going to see some questions from fragmentation and all the PYQs which have been asked in fragmentation. I mean in GATE. Okay, in GATE whatever they have asked, we are going to see all of those PYQs, including some more questions in the fragmentation. Okay, so let's just get started. So the more questions and the PYQ, all of them will be very interesting. So that's why this lecture will be quite interesting, right? Okay, so let's get started with this lecture. As the heading says that all get PYQs and even more questions, right? All get PYQs and even more questions on fragmentation. Let's just see. Okay, let's just try to solve this question. So what this question is saying is that consider a packet that has been fragmented into 3 fragments. Okay, so suppose there is a packet which has been fragmented into 3 fragments, which means there are, like, suppose fragment number 1, fragment number 2, fragment number 3. It is given that total length and the fragment offset of the middle fragment are 100. So the total length here is 100 and the fragment offset, right? Fragment offset is given to be 12 respectively. For the middle fragment, they are saying it is given. If the IP header size is 20, then what will the fragment offset of last fragment? Okay. Can you tell me the fragment offset here? That's what they're asking. Fragment offset here. So see, the total length here is 100. Then what is the length without the header? It will be 80. So 80 is the length here, right? Okay, you just try your own and just let me know what is the answer you are getting. Can you tell me the length of this? Length of this must be, it is basically, I mean, excluding the IP header. Okay, don't worry about the IP header. If it is 12, then the length of this must be how much? 96, isn't it? And what is the length of this? Length of this is 80 because the total length is 100 and the IP header size is given to be 20. So that's why length of this is 80. This is 80, this is 96. So 80 plus 96, this is the bytes that this packet is following, right? Obviously excluding the IP header. So that is why, can you tell me what is the answer that you are getting for the fragment offset here? So 80 plus 96, 80 plus 96, right? 80 plus 96 divided by 8. So which is, sorry, which is 22. Yeah. So this is 22 is the answer. Understood? Okay. Easy question. I just made it just for the sake of practice. Okay. This question was made by me. Just an easy question. I was just trying to think that, okay, if one of the fragment information is given to you, like total length and fragment offset, then can you tell me the fragment offset here? Okay. See, this total length is telling you, is giving you the hint about the length here, right? Length of this particular fragment. So which is 80. This fragment offset is giving you the hint about the length of this particular fragment, which is 96. So now you know length of this. Now you know length of this. That's why you can get the length of this also, right? Okay. Now tell me, can you also tell me the fragment? Okay, this is the fragment offset you told me. Can you tell me the total length here? The total length field here of this particular fragment? With this given information, the total length of this particular fragment? Can you tell me? No, right? This total length cannot be told, okay, by this information, because this information is either for the current fragment or for this fragment, right? For using these two fragment information, you cannot tell the length of this. You can tell the fragment offset of this, but using this middle one and this length, using these two lengths, you cannot tell what is the length of this, right? I mean, you know just the length of this, you know the length of this, but you don't know the length of this. So total length you can't tell, right? Okay, I hope you understood. Okay. So the fragment offset is 22, which is the answer. Let's do this question number 2. So what they're saying, consider a packet that has been fragmented into 5 fragments this time. Earlier it was 3 fragments, but now it is 5 fragments. Okay. I mean, that is fine, like whatever they have given, right? Okay. Now they're saying it is given that fragment offset of second and third fragments are 12 and 20 respectively. So if there are 5 fragments, let's suppose this is 1, 2, 3, 4, 5. So the second fragment, this is the first fragment, this is the second fragment. So the second fragment, fragment offset is given to you. So what is the fragment offset of the second fragment? This is given to me 12, right? This is given to me 12. I mean the fragment offset. This is 12 and this is 20. Which of the following fields can be calculated using the given information? So this is MSQ question. What is the answer you are getting? So see, if they have given the fragment offset of this, see, if they have given the fragment offset of this, using this, can you tell me the length of this? Yes, right? I mean, assuming that IP header, don't worry about the IP header. So IP header size is 20, okay? So let's not worry about the IP header for now. So it is, I mean, number of bytes, it is 96. 96 bytes, this is. Now, interestingly, this is the total length. Like they're asking, I mean, this is the length without the IP header. You can just add 20 later on. Okay. They're asking that, can you find out the total length of first fragment? Yes, you can find out. What else you can find out? You just tell me. Okay. I'm not going to solve this question. You just tell me what else you can find out. Just take your own time. So can you find out the total length of this fragment? See, let's just see. This is 20, which means what? It is following 20 into 8. 20 into 8 is 160. It is following 160, right? This total is 160. I mean, 160 bytes. This is 96. So what it will be? 160, 160 minus 96, isn't it? It will be how much? 64, right? It will be 64. Is this okay to everyone? That how we can calculate the total length of this also? Interestingly, we can calculate total length of this. I mean, this is 64. You need to add 20 for the total length. Okay. But anyway, so this 64 is okay to everyone. See, this 20 and 12, these are the only two information given to us. So we know that if this is 20, then the total bytes after it or before it, it is 20 into 8, which is 160. If this is 160, this 96 we have just calculated. So you can definitely calculate this is 64, right? So you can calculate the total length of first fragment. So you can calculate the total length of first fragment. Total length of the second fragment also you can calculate. What will be the total length of first fragment? It is 96 plus 20. For this 64 plus 20. Total length of third fragment. Can you calculate total length of third fragment? No, right? I mean, how we can calculate the information about this? Current we can't calculate, right? You don't know that what is the total length of this. You can't calculate this. You can't calculate total length of this. You can't calculate total length of this. So only the total length of this and the total length of this. These are the only two information we can calculate. Is this fine? Okay. Let me know if there is an issue here. Okay. So A and B are the correct answers here. Now let's just do one thing. Let's just see if, let's suppose the question has been asked something else. Okay, maybe let's suppose they say that you have or maybe let's suppose they say that you have 5 fragments only. Okay, 1, 2, 3, 4, 5. Suppose they say that total length of this is given. Okay, maybe total length of this is given, which is, let's suppose something, maybe let's suppose okay, maybe let's suppose 100. Okay, total length of this is given to be 100. This is the total length of this, right? Okay, and now they are also saying, so this is the total length. Now suppose they're also saying the fragment offset is also given for some of the fragments. Suppose the fragment offset is given for one of the fragment, which is, let's suppose this one. Okay, the fragment offset of this is, let's suppose, given to be 5. This is the fragment offset of this particular fragment, and this is a total length here. Now tell me, can you calculate the fragment offset of this particular fragment? Can you calculate the fragment offset of this particular fragment? Just see if you can calculate. See, If the fragment offset here is given, then they are saying that this bytes is actually 40, the total length. I mean, you can calculate the total length, but I'm just writing the length without the header. So they are saying this is 40. They are saying this is 80. I mean, without the header, it is given to be 80. And if this is 5, it means like next is 40. Okay. That's all right. What they have asked, the fragment offset of this. So now you know this, but somehow you don't know this, right? I mean, you don't know the length of this. Okay. You don't know the length of this. So that is why you cannot calculate the fragment offset here. Now, suppose they say that the question is that this total length is given, this fragment offset is given. Now the question is something else. The question is saying that which of the following information is sufficient additional information is sufficient to know, to calculate total length of, this is first, second, third, and fourth. Okay. Fourth fragment. One option is that fragment offset of third fragment, total length of second fragment. Option C is, so they want the total length here, right? Okay. So option C is fragment offset of fifth fragment, right? And option D is all of these. Sorry, let's have none of these. Okay, none of these. Let's suppose this is MSQ question. So they are saying that you are given 80 here, 40 here. Okay, you know 80 here and 40 here. And now you want to know that what is the total number of bytes. I mean, basically you want to know the length here, right? So basically you want to know the fragment offset of this. So which means if you know somehow the length here, then you can calculate the fragment of the offset of this. So 80 and 40 are given. So what do you think? What is the sufficient information? Fragment offset of the third fragment. If they give the fragment offset here, sorry, the third fragment. If they give the fragment offset of this, then can you tell me? Can you tell me what is the fragment offset of this? Yes, right. So if they give you the fragment offset of this, then you know how many bytes it is following. So total number of bytes you anyhow know that how many bytes it is following. So if they give the fragment offset of this, then the fragment offset of this is given and the total length of this is already given, right? So you can calculate that how many bytes this is following. So basically you can calculate that how many bytes this is following, right? So yes, this information, I think A is sufficient. What else? Total length of the second fragment. If they give the total length of the second fragment, is this good enough? What do you think to calculate the fragment offset of this, that how many bytes are there totally? Yes, I think that is fine. The fragment offset of fifth fragment. If the fragment offset here, the total, if they give you total here, then will this help you, the total here? No, right? No. Suppose, just for the sake of variation, I just modify this and fragment offset of this. So basically, let's suppose they give two information, the fragment offset of this and total length of fourth fragment. and total length of fourth fragment. So what do you think? Is this option good enough? If they give the fragment offset here, if they tell you that what is the total number of bytes here, they tell you this total, right? They tell you this total, and they are also telling the total length of this, which means they are telling this total, right? Total length of this. They also tell you this particular whole total. They tell you this also. You know these things. You can calculate this, and then you can calculate the fragment offset here, right? Are you getting my point? So basically, then C will also be the answer. In that case, you can say C is also the answer. Understood? Okay. So, I mean, I hope now you are a little more comfortable that how we are calculating the fragment offset and these things, right? Easy question only. Easy question only. If you want, we can do one more practice. B and C is not sufficient for the previous case. B and C, why? Total length, if they give you the total length here, then see what you want to know. You want to know the like all of the length here, right? I mean, you want to know the fragment offset of this. Once you know all of this length, then you can definitely divide by 8, and then you can get the fragment offset of this. If they give you the total length of the second fragment, then also you can get all of this, right? You want to know all of this all together, right? If they give you fragment offset of the fifth fragment, which means they give you all of this, and they give you this also, then can you calculate this? Once you calculate this, then can't you calculate all of this? See, your ultimate aim is to calculate this total, right? This total. So C option is saying that we are giving you fragment offset here, which means we are giving you this total and this total also. We are giving you this total length also, right? If they give you this particular thing and the whole of this, which means the including all of this, so then you can subtract, and then you can get this much, right? Okay. And then you can tell the fragment offset here. Okay. Last question took me by surprise. I thought Sangeet is saying we need to. I thought we need to make equal length fragments, excluding the last fragment. That is true only when you are sending on the same link. I mean, like equal length fragments are generally the case, but it is not always the case. Which means we can have unequal length fragments also. That's perfectly fine. For example, if you are let's suppose at this router, and then you need to send to two routers. Okay, I mean you want to distribute the load. Okay, you want to send to two routers. This is having, let's suppose, 500 MTU. This is having, let's suppose, 1500 MTU, right? Something like this. Then what you can do, you can definitely divide your packet into let's suppose this is 4000 bytes, into such that some fragments you can send here, some fragments you can send here. Okay, I mean if the links are having different MTU, then you can send with different I mean different basically length of the fragments. Like for example, see, for example, we will solve this question a little later, but is this diagram visible to everyone? See, this diagram is from CM. Okay, that link I don't have, but this diagram is from CMU University. So this at A, if you are at B, okay, if you are sending from B, the question is about this only. If you are sending from B, then you can send here also, right? You can send from B to C also. You can send from B to D also. So depending on the different MTU, you can divide the same packet into different sizes. Okay, we will see this question later on. But yeah, your doubt was very nice. Okay. You asked very nice doubt that that can be divided into different length. Yeah, depending on the MTUs, right? You can definitely do it. Okay. Now let's see this question. This question is saying an IPv4 packet includes a TCP segment. The IPv4 packet needs to be fragmented. Which fragments include the IP header, the original IP header, and which fragments include the TCP header? So they are saying that we have IPv4 fragment. This is IP header. This particular needs to be fragmented. Now, which of the which of the particular fragment is having the original IP header, and there will be TCP header also, right? This will be TCP header, and which is having the TCP header. All fragments include original IP header. Do you think? None, right? No one is including this original IP header. See, this original IP header is not of my use even, right? So what we will be doing, we will be fragmenting this particular thing, right? We will be fragmenting this particular thing. So So none is having this original IP header. We have already talked about these things, right? In the previous classes. So basically none is having this original IP header. All header include original IP? No, no, definitely not. Only first fragment include the original IP header? No, no one is including, right? All fragment include the TCP header? What do you think? This is also no. Basically, this TCP header will be just in. I mean, I'm saying here is that there will be, this is the payload, and then this TCP header will be in just first fragment, right? The first fragment only. Okay, this TCP header will be in the first fragment. This is the first fragment. This is the second fragment. So basically, this TCP, UDP, or whatever the fragments that the headers you have, that will be only in the first fragment. Anyway, these particular fragments does not even require the TCP header, right? I mean, because these will be processed by the router, and router doesn't even require the TCP header. This TCP header will be only in the first fragment. See this particular diagram which I have taken from Berkeley University. So they are saying that if you have this particular thing, then this TCP, HTTP, whatever header you have, that will be just in the first fragment, right? That is just in the first fragment. See, this is the first fragment that they are saying. This is the second fragment they are saying. This is the third fragment. Now tell me, this TCP, HTTP, or whatever header you have, that is just in the first fragment only, right? In the second fragment, there is nothing. In the third fragment, there is nothing. So anyway, it also makes sense. I mean, for the router doesn't need the TCP headers and so on. Router just forward based on the routing table, and for that they need the IP address, and IP address in the IP header. So they don't need the TCP header. So these fragments anyway doesn't need the TCP header, right? So hence, what is the answer here? All fragments? No, only the first fragment includes the TCP header, right? Here I'm obviously assuming that the TCP header is contained as whole. I mean, it's not like that the TCP like packet is too small. The TCP header itself has to be divided. Okay. I mean, I'm just assuming that. Okay. Anyway. Cool. Now let's just solve this question. This question is from GATE 2013. Has anybody solved this question? Because I have already uploaded it. So let's just see this question. In an IPv4 datagram, the more fragment bit is 0. Okay, they are saying that more fragment bit is already 0. The value of header length field is 10. Okay, see, they are saying the value of header length field is 10. So will you be getting confused that this is the actual header length, or you need to multiply by 4? See, will you be multiplying by 4, or you might get confused, this is the actual header length? Tell me. See, the thing here is that the actual header length ranges, minimum 20. Do you remember? Minimum 20, maximum 60. So the actual header length, basically this header length, they are talking about the header length field. So the actual header length range, the number range will be from 20 to 60. But if they say that header length field, then it will be containing from 0 to 15 only, or maybe from 4 to 15. I mean, because of minimum to, 5 to 15. Right? Because this is 20, so that's why this is 5, this is 60, that's why this is 15. So if the range is between 5 to 15, then they are talking about the header length field. If the range is between 20 to 60, then they are talking about the actual header. By the way, it will not be confusion even if you don't do this kind of analysis. Reason being is that they will just tell that, I mean, they're telling the HLEN, which is clearly means header length field, right? They're talking about the header length field. If they have to say the header length, they will write the complete header length like that. They will not say HLEN, right? And also it is clear that there should not be any confusion that you should be multiplying by 4 or not. If this is between 5 to 15, then obviously you need to multiply by 4. I mean, if this is not matching this 22, you can say 60. If this is not 20 to 60, you multiply by 4. Okay. Anyway, so what is the header length here? Header length is 40. More fragment is 0. It means it is a last fragment, right? Okay, it is a last fragment. This is 40. The value of the total length field is 400, which means the IP data is 360. The fragment offset value is 300. So which means they are saying that fragment offset is 300, which means after it, how many bytes are there? 300 into 8, which is 2400 bytes are there. Okay. So these are the 2400 bytes. And then they are saying that this is 360 length, okay, without the IP header, obviously. Okay. So first of all, this is the last fragment. That is for sure, because there are no more fragments. This is the last fragment. And then they are saying that what is the byte, first byte and the last byte number? What is the first byte number? See, this is from 0 to 2399. So what should be the first byte number? 2400. What is the last byte number? 2400 plus 360 minus 1. Something like that, right? So first of all, this is the last fragment. And then you can just add 360 here. So it will be 0672. So 2759, right? 2759. So C is the correct answer here. I mean, you need to subtract 1 because indexing is from 0. Okay. So do you remember this question we have already solved? Do you even remember the source of that question? So C is the correct answer here. But do you remember that we have already solved this kind of question? Right? From which book? From Forogen. Also, do you remember that I told you that in computer networks, there will be many times that I will actually one-to-one map. Okay. See, this is a good gate question. This is a standard book or a standard university question. There will be many times that I will be just matching one-to-one. Okay. That this is a gate question. This is a standard university or some book question. Do you remember? I've told it many times. That for computer networks in the gate PYQs, actually I found it. I don't know, somehow that I found it that they have copied directly from a standard textbook or from the standard universities. Okay. And there has been many questions that we have seen that, okay, they have copied. So this question is again copied from Forogen that we have seen in the last class, right? Maybe if you want, I can just show you. Yeah, this one, right? Do we know the number of the last byte? Something like this, right? Do we know the number of last byte? Do we know the number of first byte? Okay. I think that was the question. Yeah, this was the question, that the value of total length and these what are the number of first and last byte, something like that. This was the question from Forogen and the example 19.10. Anyway, like in the computer networks, this is what I observed, that they have asked many times just from the standard textbooks, right? Okay. Now let's just see this question. Satyam is saying, I feel standard sources are copying from Gate. Do you really think so? Do you really think that Forogen needs to really copy from someone? Okay, so they, you can check their additions also. I'm damn sure that they do not need to copy from Gate. So let's just solve this question. What this question is saying, then I, okay, so don't say this again. Okay, that standard textbooks are copying from Gate. So Gate questions are made by Indian professor, which is okay. I mean, they're also very much capable, but this standard textbooks have been there since very long. And why they are standard? Because everyone is following them, and there is a reason why the whole world is following just 2-3 textbook for a particular subject, right? It's not like that they are copying something. There is a reason that whole world, every other university is following just 2-3 textbook for particular subject. Okay, so let's just see this. This question has been asked in GATE 2016. So what they're saying, an IP datagram of size 1000 bytes arrive at a router. The router has to forward this packet on a link. Its MTU is 100 bytes. Okay, so this datagram size is given. So which means that what is the IP data? Is 980. Now this 980 should be divided into 80, right? Into 80. Okay. So the number of fragments that IP datagram will be divided into the transmission edge. So you just need to find out the number of fragments. I think this is easy question only. So you just do 980 divided by 80. What you're getting? 12 point something, right? 12 point something means 13. So this is 13. I think this is very easy question. Okay. 13 datagrams. Understood? Just see that, okay, 980 divided by 80, how much it is coming? 12 point something. So which means 12 will be containing 80. Last one will be containing lesser than 80, right? Okay. Now you tell me, here, is this divisible by 8, this number? Yes, this number is divisible by 8. So that's why you don't need to worry about anything, right? Okay. Let's just see this question. What they are saying: consider an IP packet with the length of 4,500 bytes. Okay. So just consider that there is an IP packet with the length of 4,500 bytes that include the 20 byte IP before header. So what does this mean? It means what is the IP data? 4480, right? 4480. Now they are saying that there is a, okay, they have also given the TCP header. Interesting, right? So they are saying that there's a 20 bytes of IP header and then 4480 is this. Out of this, the TCP header is also given to be 40 bytes. So this TCP header is 40 bytes. So now can you tell me this much? This will be 4440. Okay. The packet is forwarded to the IP router that supports the maximum MTU of this, which means if this is the MTU, then what is the data it can carry? 580, or you also need to subtract the TCP header because it is given, right? The TCP header is also given. See, the TCP header is just to confuse you here. TCP header won't make any sense. Okay. So it can carry 580, but I think 580 is not divisible by 8. So you just take the, take the closest to it, which is, I think, 576, but that is fine. So anyway, so this TCP header information is actually misleading. As we have seen many times, right? So this TCP header is not useful here in the datagram or in the fragmentation questions. Okay, so let's not even consider this information. I mean, the data that is given to us is basically they are saying that is 4480, and then the MTU is given to us is basically 600, which means this 4480 has to be divided into the sizes of 580 each. But I think 580 is not multiple of 8. So what is the nearest one? If you check the 580 divided by 8, then it is 72.5. So you can just subtract 4, right? Because 0.5 is 4. So which means, or maybe you can, if you want, 72 into 8, right? So this is 576. Okay. So this is 576. Now 576. So how many it will be there? 4480 divided by 576. It will be 576. And then this is the 8th one, right? Okay. So this is 576. These are the 7 fragments. And there will be the 8th one. What is the size of 8th one? It will be something you can calculate. So let's just see what they are saying. Assume the fragmentation offset value stored in the first fragment is 0. Okay. The fragment offset value is stored in the third fragment. So they're asking just about the third fragment, which means they're asking about this. What is the fragment offset value here? Easy question only, right? So 576 divided by 2. Oh, sorry, 576 multiplied by 2, or maybe 576 divided by 8 into 2, which is 144, right? Yeah. So this is the fragment offset here will be 144. Okay. So see this TCP information, whatever is given to you. I mean, actually in the good answer, it should be mentioned that the TCP information is not needed and all. But I mean, it should be mentioned in the given answer. It's not like that they should. Do you think that good answers should not even mention the TCP? Right? They should at least mention that, okay, what should we do with this information and how they are trying to confuse us and how we should not get confused, right? So this answer, if you want, you can write a nice answer where you can clearly write that, okay, what is happening with the TCP header, right? You can definitely attach this particular diagram if you want. The TCP header is only in the first, right? Remaining doesn't have the TCP header. And anyway, the routers doesn't need the TCP header. You can include these 2 points. And the third point could be that only the first header will be, the first point could be only the first fragment will be having the TCP header. Only the first fragment, right? Only the first fragment have the TCP header. Second point could be the routers doesn't need even the TCP information. Okay. And the third point could be, for any fragmentation question, we can completely ignore information given about the TCP header or HTTP or these things, right? So you can include these 2-3 points and then you can try to answer this question if you want to. Okay. Now let's just solve this question. This question has been asked in GATE 2014. So what they are trying to say, An IP router with the MTU is given to you is 1500 bytes, right? An IP packet of size 4404 and the IP packet of these mesh size and the IP header length is also given. So which means 4404 minus 20. What it will be? 4404 minus 20. 4384. So now what you need to do? You need to divide this 4384 into 1480, right? 1480. The values of the relevant fields in the header of the third IP fragment they are asking. So it will be 1480, right? It will be again 1480. So here they're asking the more fragment will be, will there be more fragment? What do you think? 4384 divided by 1480. So there is no more fragment. Okay, so basically this is not even the 1480. This will be something else, right? Anyway, let's not calculate the size. If you want, you can calculate. But yeah, there will be no more fragment. So there are no more fragments. So which means more fragment field is 0. That's fine. So either A or D is the answer. Datagram length. Okay, the total length basically. Datagram length here means the total length. So what is the total length here? You can calculate this 1480 multiplied by 2, right? And then you need to subtract that from 4384. So 1424. So this is 1424. The total length, like the without the IP header, this is 1424. But you need to add 20, right? You need to enter 20. So that is why the answer is very clear, which is A is the answer here. More fragment, and this is the datagram length 11444, right? And this is only the IP data. This is not including the header size. Okay. So do you think that the datagram length here, what does this mean? Do you think the datagram length might be including the header or might not be including the header? Will you be getting this confusion? See, let's suppose one of the option is this. Okay. Let's suppose one of the option is this. Can you tell me which one you will be taking, or you will be getting confused that, okay, this IP header is included or not in the datagram length? Let's suppose this is one of the option. Now you tell me that A is the answer or D is the answer. The only difference here is this. Why A? Why you are not getting confused that this datagram length is including the IP header or not? Why you are not getting confused? Can anyone give me the nice answer here? Why there should not be any confusion? That this datagram length means including, this is the total length. Can anyone give me the nice answer? Why this is the total length? Because they're saying the fields in the header, right? The fields in the header. Do you think that you have any field in the header which is without the total length? Or you have the total length, you have total length, you have identifier, you have fragment offset, you have more fragment. You do not have any field which is without the header length, right? You have header length, you have total length. So if they're saying the fields in the header, then will there be any room for the confusion? Are you getting my point? So fields in the, can you tell me the fields in the header? Header length is one of the field here, right? The total length is one of the field. If you want the length which is without the header, you can subtract it, right? I mean, that is fine. You can definitely subtract it. But tell me, is there any field which is telling you the length without the header? No, right? So they're saying that which of the, I mean, we need to match with the fields in the header. So the fields in the header can be more fragment, can be offset, and this must mean the total length. If they're saying the fields in the header, right? Anyway, the datagram length always mean the total length. I mean, datagram means that including the header, but still I'm saying that there should not be any confusion because they're talking about the fields of the header. Understood? Or my point is not clear? Let me know if my point is clear. Okay, clear, right? Okay, so fields in the header must mean the total length, because there is no field in the header which is not without the header length, right? Okay, so here the answer is A. Easy question. Have you seen any question which was anyway even the little tricky in the PYQs till now? See, if I just quickly tell you what are the PYQs that we have solved. This was the first PYQ. Anyway, that was copied from Forogen. That was the only little tricky. That first byte number, second the last byte number. That was the anyway little tricky. All the questions are just a standard question, right? How many number of fragment offset, and these things, right? Fragment offset, the fragment offset value, and these things, right? Okay. Now let's just solve this question. This question has been asking in 2015. So what they're saying, host A sends UDP datagram containing 8880 bytes of user data to host B over an Ethernet line. So they're saying there is a UDP. Okay, currently you don't know what is UDP, what is TCP, but for this question, it won't be basically much useful. So they're saying 8880 bytes of UDP of the user data basically you are sending, right? Okay. In the Ethernet line, the MTU of line must be given. The Ethernet may carry up to, okay, the MTU is given here. Size of the UDP header is 8 bytes and size of the IP header is 20 bytes. There is no option field. So basically they are saying this is the user data that you have. And on top of that, what you have? You have UDP of size 8 and IP of size 20. This is the user data. You will get to understand that what are these terminologies later. But for now, just follow this, that this is a user data. On top of that, there is a UDP header. On top of that, there is a IP header. Okay. How many total number of IP fragments will be transmitted? What will the content and offset of the last fragment? Okay. So they have given you the UDP information here. Now you tell me, will this header will be in the each fragment? Will this header will be in the each fragment? No, right? So can you just solve this question? Can you just solve this question immediately by just assuming that, okay, this is 8888, right? So basically you need to divide 8888. Finally, you need to divide 8888 into multiple parts. And what are those parts? So 1480, right? So you can just see 8888 divided by 1480. 6 point something, right? Okay. Which means there will be 7 fragments. 1, 2, 3, 4, 5, 6, and 7 fragments. Now what they are saying? How many total number of IP fragments will be transmitted? What will the content? How many total number of IP fragments? 7 fragments you are going to transmit. And what is the offset of the last? So what is the offset of the last? 1480 into 6 divided by 8. 1480 into 6 divided by 8. 1110. So what is the answer here? C is the correct answer, right? Okay, let me know if that is okay to everyone. User data means that you need to append the UDP header. Okay, this terminology will be little clear later on because currently we have not seen this transport layer or application layer. So user data means you need to append the UDP header, and then you will be appending the IP header anyway, right? Then you will be appending the Ethernet header. That is also fine, but that information is anyway not needed, right? So you will be fragmenting this particular thing, right? You will be fragmenting this particular thing. So there will be 7 fragments. 6 will be having 1480. There will be somewhere last. I mean, last will be having something, and then they are asking about the fragment offset of last. So there are 7 and 1110, right? Answer is C. See, this question has got 122 upvotes. I mean, the answer has got 122 upvotes. No, that's not UDP datagram. That's basically, I mean, they are saying that these many bytes of user data. So user data means without including the UDP header. Okay, I mean, that is directly coming from the application. This is the user data. So again, I'm saying this terminology will be clear later on. For now, just follow that this is the user data, and then you need to append the UDP header. Okay, the terminology about the user data and these things will be clear later on. Okay, cool. Understood this question? Was there any difficulty in this solving this question apart from this terminology? Don't worry about this terminology. Suppose if I give you directly this, then will there be any difficulty? No, right? You may at max get confused that, okay, should we append this UDP header everywhere and so on? But now I think this must be clear. This UDP header is basically the part of just one fragment. Okay, the first fragment. Okay. So you can see that there has been 122 upvotes for this particular question. And you can see my comment also. I have commented, this is 6 years back, right? Maybe more than 6 years, little more than 6 years. I mean 6.5 years something. So this is 6.5 years back. I have commented something like this, that only the first fragment contain the UDP header, else don't, right? So this makes sense too, as the router don't need the UDP header at the destination. After assembly, at the destination, it is going to be one packet anyway. The to travel intermediate routers, we don't need the UDP header, right? So this particular comment I have done 6.5 years back during my preparation. No, at my time, actually, I have not read any of the book. So Flora is asking, have I read the books at my time? So I think Forogen, maybe little bit I have read, but I have not read any of the book. My strategy was to just follow the PYQ rigorously. Okay. So I was following the PYQs very rigorously, in the sense that for every PYQ, I was digging too deep, that, okay, what is happening, what is not happening. I mean, you might have seen my participation mostly in the PYQs only. Okay, my comments are there in the in the PYQs. Wherever I found that, okay, I can contribute, I have contributed. And then actually I have bookmarked many questions that, okay, I will be contributing later on after the gate result. I will be after the gate exam, I will be contributing. So I have bookmarked many questions. But you know that, okay, after rank everyone get lazy. So I got lazy, and I don't even have that list of that questions. So I wanted to contribute more, but due to lack of the time, I have contributed only in the less questions. Okay. So now let's just move to the next question. So this question was nice. They were just trying to confuse you with the UDP header. Okay. Don't get confused that this UDP header will be in the every fragment, or what will happen with the UDP header. No, you don't need to fragment this. Okay. Let's just suppose, I mean, I think they must have made it so cleverly. Suppose someone just do the mistake, and suppose that someone says that, okay, I will be fragmenting this. Okay, I'm assuming they must have made this question a little cleverly. So can you fragment this? How many fragments will be there? 8880 divided by 1480, right? So 6 fragments. See, exactly 6. Okay, how cleverly they have formed this question. Exactly 6 it is coming. 1480, 1480, right? 1480, 1480. 1480, 1480, right? So what could be the wrong answer? That 6, I mean, someone can fragment this. So 6 will be the fragments. And what is the last fragment? 1480 into 5 divided by 8, which is 9 to 5, right? So let's just see if any of them. See, A. And you will be very happy. Okay, you got A as an answer, right? So you don't need to fragment this. This is wrong. Okay, we should not fragment this. Using this wrong concept, answer is 9 to 5, right? Okay, which is it? Their intention you got, right? What was their intention? To see whether you are understanding that UDP should be the part of the fragmentation, or it is not part of the fragmentation. Their intention is very clear to make this question. Now let's just see this question, which has been asked in GATE 2004. So what they're saying, a TCP message, just a second. I was just seeing the question. I mean, what they have written. TCP or UDP header will be added to the data unit received from the transport layer to the network layer, and the fragmentation header. So no need to. Do you really think this no need? No need is a good word here. It's not no need. It's like we will not do it, right? We are fragmenting the IP data. we will not do it. So I mean, like what I'm saying, that that you can improve the answers if you want, right? You can write your own answers. I mean, these little things just reflect that how much conceptually clear you are. Okay, how much conceptually clear you are. Okay, if you can't edit the answer, just comment it out. Just comment it out that the last statement should be this much. Okay. So now let's just see this particular question, which has been asked in greater than 4. So what they're saying, a TCP message consisting of 2100 bytes. So there's a TCP message that has these many bytes is passed to IP for the delivery across 2 networks. Okay. So basically there's a TCP message which is containing 2100. Now you are passing it to IP. This IP will be appending its own IP header, right? This is 2100 and IP header size is given to be 20 bytes. Okay. This is 20. Now what else they are saying? Maximum payload of the first network can carry the maximum payload of 1200 bytes. Okay, the MTU is given to you is how much per frame, and the second network can carry 400. So the MTU one, which means they are saying that this is this packet. Okay, the packet is basically 20 here and 2100 here. That is passing through 2 networks. The first network is having the MTU of how much? 1200 bytes. So basically, this is the MTU, okay? Which means you need to subtract 20 here. This is MTU, 400 bytes is MTU. Excluding the excluding network overhead. Okay, network can carry the maximum payload of 400 bytes per frame. Okay, this is not the MTU, right? Because MTU include the network overhead, right? So they are saying excluding the network overhead, you can carry this much. Okay, if you do not include the network overhead, then you can carry this much. Okay, this is not the MTU. This is the actual, I mean, the network data that you can carry, because the MTU actually include the IP header. Okay, and this whole thing that you can carry is basically called MTU. So I think this is not the MTU. So let's just see what else they have given. What is the total IP overhead in the second network in this transmission? Okay, so basically this is the first network by which that will pass through, and then it will be passing through this 400 bytes of I mean, this is not the MTU, but 400 bytes it can carry, excluding the IP. So you just worry about this IP. Now, how many fragments will be here at this point in time? This 2100 will be fragmented into how many parts? This 2100 will be 1200. This will be 1, and then what will the remaining one? 900, right? 900. So 900 and 1200. Now this 900 will be divided into how many parts? It will be divided into 400, 400 and 100, right? This 1200 will be divided into how many parts? 1200 will be 400, 400 and 400. So there will be six IP packets that you will be having here. So what is the total IP overhead in the second network in this transmission? So what is the total IP overhead? Means IP data, IP header sizes. I mean total IP header sizes. So what it will be? So the total IP header sizes will be 120, right? 120 bytes. At source, TCP passes this much to IP layer. IP appends 20 bytes on data link layer and so on. We are interested. Okay. A router on the way is highest as a network layer, so the complete TCP is fragmented. And the question given is maximum payload without, yeah, that's nice. Maximum payload without the network overhead means they have directly given the amount of IP data that the network can carry, right? So the amount of IP data that network can carry directly is given to 1200 bytes. So MTU actually include the IP header. So they are saying excluding the IP header, we are directly giving you. Okay. So in this question, the variation, I mean, kind of, it's not very nice variation to be honest, but yeah. So the variation that they did is just without the MTU, they just told what is the network can carry. I mean, the IP data it can carry. Is this okay to everyone? That how we are solving this question? Okay. So if you are a little bit confused in this particular term, the TCP message containing these many bytes, is this including the header, not including a header? So don't worry about this TCP UDP terminologies. There are different terminology at TCP UDP. There are different terminology at network layer. And at the network layer, we will talk about it later. At network layer, we call it datagram. Okay. At data link layer, generally we call it frame. At the TCP UDP, we call it sometimes message, sometimes segment. So we will talk about these terminology later. Okay. So at that time, you will not be having any confusion. Cool. So this is the TCP message. This completely is a TCP message. Then you will be appending IP header. And then these particular numbers are given without the IP header, excluding the IP header, they are saying. Okay. Now let's solve this question, which has been asked in very recently, which is GATE 2021. So what they're saying, consider two host P and Q connected through a router R. So let's just try solving this question. So they are saying that P and Q are connected through a router R. P and R is 1500 bytes. So this MTU is given to you is 1500 bytes. This is given to you is 820 bytes. Okay. TCP segment size of 1400 bytes was transferred from P to Q. Okay. So here is a TCP segment of 1400 bytes that you want to send from P to Q through router R. And there is a IP identification 1234 if the hexadecimal is given to you. Assume that IP header size is 20 bytes. Further packet is allowed to be fragmented. Okay. Don't fragment field is not set. Which of the following is true? Okay. Do you want to take some time to solve this question? Just try out. Let's just see what you're getting. So by the way, this is MSQ question. Okay. So this is a MSQ question because it is written here. It is multi-select. So this is MSQ question. So this TCP segment is given to you of 1400 bytes, right? Okay. I mean, the segment means that you have the header included. So which means there will be directly IP header now. Okay. TCP segment or TCP message means you already have the header included. So this is header included, TCP header included, right? So now they're asking that what is happening. It's easy question only. So this is 1400 bytes. This is the data that you want to fragment. So tell me, will there be any problem on this link? On this link, I don't think there is any problem. It will be just fragmented here. So this is 1400. You want to divide into 800 and 600. That's all. So how many fragments? There will be 2 fragments created at R. The IP datagram size carrying, I mean, the total length will be 620 and 820. So the total length of the second fragment is 620. Yeah, that is correct. If the second fragment is lost, R will resend the fragment with IP identification of this value. No, if any of the fragment is lost, basically the whole fragment will be sent. I mean, I don't have, first of all, I don't have any copy of this, right? The whole fragment will be sent using the P. Okay, the whole fragment or the whole packet again. So it's not like the like P don't even know that there is a fragmentation or not, right? P doesn't even know. Fragmentation is at R. First of all, even though P know, it doesn't send the fragments. It will be sending the whole packet. Okay. Okay. So if P is a source and the fragmentation can also happen at the source, which means if P itself is sending the fragmented packet, then only it will be sending the fragments. Which means, see what I'm saying. Let's suppose this is P. This is some R, this is Q, right? So now just listen here carefully. The TCP is giving you 1400 bytes of data, and then this is 20 bytes of IP. Okay. Now let's suppose somehow I'm saying this itself is 820. Will this be able to travel here? Will this be able to travel? No. At this time, who is fragmenting? The source. Okay, not the intermediate router. If the source is fragmenting, then the fragment itself is an independent packet. Okay, if source is fragmenting, so here the source will be fragmenting and the fragment itself will be the independent packets, which means it will be sending this 820 and 620. If source itself is fragmenting, then it's a altogether different independent packets. There is no fragmentation as such. I mean, if intermediate routers are fragmenting, then the field of the fragment offset and these things comes into the picture. So here here, if source itself is fragmenting, tell me what is the field of more fragment here? What is the field of more fragment here? If the source is fragmenting. Think about it. So the more fragments fields will be 0. I mean, these are just independent packets. You can just think as an independent packets here, right? If the source itself is fragmenting. But now let's suppose that instead of this scenario, I mean, this is just one scenario, the source is fragmenting. But let's suppose the scenario here is different, which means the routers are fragmenting. If router is fragmenting, then the scenario is different, which means, let's suppose the MTU here is some 1500 or something, right? 1500. And here, the MTU is 820. If this packet is coming, then will there be fragmentation at R? Yes, there will be fragmentation at R. It will be 800 and it will be 620, right? Because this is 820. Now tell me the more fragment here. This will be, yes, there are more fragments. There are no more fragments, right? Now there will be the fragmentation. Okay. So if source is fragmenting, that's not an issue. Is that fine to everyone? Okay. Now let's suppose one of the fragment here, I mean, let's suppose this intermediate router R is fragmenting. One of the fragment here is getting lost. Okay. Somehow it is getting lost. Now, will R be sending this fragment again? The fragment, this fragment again? No, right? R doesn't even have the copy of this thing. So the whole fragment again will be sent. If any one of the fragment is lost, then the whole fragment again will be sent. Okay. So this will again be sent. This the whole packet again be sent. So this is 1500 bytes. This is 820 bytes. If you are sending some packet, let's suppose, which is 1400 bytes, right? Then it will not be, I mean, the 20 bytes of header. So it will not be a problem here. So you will be sending here. And now maybe I can go to the next page. See what is happening. That you want to send this 1400, right? 1400 and the 20 bytes is header. So there will not be any problem here. There will be a problem here. If this is M2U, so you will be basically dividing that into 800 and 600. That's all. So this is 1400, which will get divided into 800 and 600. Now, this 800 bytes is basically, I mean, this particular fragment, or maybe this fragment. Let's suppose one of the fragment is getting lost on this link. Then what will happen? If these are the two fragments traveling and one of the fragment is getting lost, then will RB sending that particular fragment again? No. So what will happen in that case? In that case, this P will be again sending this complete datagram. P will be again sending this complete datagram. We will see this in today's class only. We will see more questions about it. But I hope this is the first question. As a first question, you understood that if any of the fragment is lost, then obviously like P will be sending the complete datagram again, which is 1420. Okay, it's not like the fragment individually can be sent because R doesn't have copy. Okay, R can't even have the copy because there are many communication is happening. If R is keep on having the copy, it won't be scalable, right? Okay, that's very obvious thing that R cannot have the copies. So two fragments will be created at R, and IP datagram size carrying the second fragment is 620 bytes. Yes, I mean the total length will be 620. This is without the IP header. So A is the correct answer. If the second fragment is lost, R will resend the fragment with the IP identification value this? No. R cannot resend. What about C? If the second fragment is lost, P is required to resend the whole TCP segment? Yes. TCP destination port can be determined by analyzing only the second fragment. Okay, so anything about the TCP, can it be, I currently don't know what is the TCP header, what is the destination port, but let's suppose there's a TCP header. In that there's a destination port or something, right? Can you check the destination port using the second fragment? What do you think? No, right? Because this destination port is in the TCP header, and TCP header is not even the second fragment. See, that is the fragmentation, as I told you multiple times, that this is IP, this is TCP. Then this is the first fragment, this is the second fragment. The second fragment doesn't even have the TCP header, right? So that's why D is also the incorrect answer. So A and C are the correct answers. Okay, let's just see. A is correct, C is correct. First of all, it says ID is optional. They have not even talked about D, right? Okay, D they have not talked about, but yeah, D is also incorrect. Why that is incorrect? You got the answer. Would you like to add that as a comment, that why D is incorrect? If you want, what you can do, you can also write all the gate PYQs. Okay, I mean, whatever the gate PYQs there, you can also write the link of those PYQs that were dealing with the TCP header, and that was only in the first in the first segment. And also you can add this link, this Berkeley link, right? Berkeley University link, that see the TCP header is always only in the first fragment. Okay, if you want, you can just add as a comment that why D is false. Is this fine to everyone? So you can add that as a comment also. Okay, that why D is incorrect. Now let's see this question. In TCP or IP protocol suite, which of the following is not part of IP header? IP header का part कौन नहीं है? Fragment offset is a part, source IP is a part, destination IP is a part. D is the answer, right? Okay, that was just easy question. So let's now solve this question. What they're saying, this question is taken from Stanford. So what they're saying is that suppose node A sends a 1280 byte IP before datagram to E. Okay, so A is sending to E, and this packet needs to travel a path having 3 routers and 4 links. So basically A is sending to E, which is having 3 routers. Let's suppose BCD, and A is sending to E, right? So 3 routers and 1, 2, 3, 4 link. Okay. Now, what is the size of IP before datagram which is given to you? 1280 bytes, right? And IP header size is also given to 40 bytes. So which means that you need to divide how many bytes? You need to divide 1240, right? 1240 bytes. So you need to divide 1240 bytes. And what is the MTU that they have given? Each link has the MTU of 660 bytes. So if this is the MTU, then what is the IP data it can carry? So basically, out of the 660, you can only carry IP header size you need to remove. So 620, right? 620 bytes you can carry basically. So how many fragments it will be? 2 fragments, 620 and 620, right? Okay. Now what they're saying, each link has MTU of, okay, that is fine, and drops with the 50% of the packet. I mean, each link can drop the 50% of the packet. This is interesting. Okay, due to bit errors. What is the probability that datagram will successfully reach to E? So let's just see this question. Okay, so they are saying that you are sending something from A to E. You are sending something from A to E, and further they are saying that there are 2 fragments basically, right? Let's not worry about the size of the fragment and so on. Let's say there are 2 fragments that you are sending from A to E. Now they're saying that what is the probability that these fragments will successfully reach to E? What is that probability? If each of the link can drop any of the fragment with 1/2 probability, that each of the link can drop any of the fragment. So when I say that when will I say that these 2 fragments are getting successfully delivered to E? Whenever, I mean, when will I say that this is a 1 packet, right? This is a 1 packet which got fragmented into two pieces. So when will I say that this 1 packet is successfully delivered to E? Whenever both the fragments are reached. So basically, I want this fragment also to be reached, and I want this fragment also to be reached. Can you tell me what is the probability of this fragment to be reached to E? With 1/2 probability, it will be surviving here. With 1/2 probability, it will be surviving here. 1/2 probability, it will be reaching to D. With 1/2 probability, it will be reaching to D to E. So for the first fragment, 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2, right? This will reach to E with this much probability. So basically 1 by 2 power 4. With this probability, it will reach to E. I want the second fragment also to reach to E. So what is the probability the second fragment also reach to E? The same probability. And why I'm multiplying? Because I want both of the things to happen. Then only I will say that the whole packet has been reached to E. So with this probability, the whole packet will be reached to E, which is 1 by 2 power 8, which is 1 upon 256. Right? So A is the correct answer here. Okay. So success of the datagram is basically first fragment success and the second fragment success. Okay. So this is the first fragment reach. This is and second fragment reach. Okay. Cool. Now, does fragmenting increase or decrease the likelihood of dropping of the packet? If there are fragments, then do you think that that there are chance of the packet being lost is more or less? If again, this is from Stanford. So if there are fragments, the chance of the dropping of the packet is more or less? It is more. Why? Because if any of the fragment is losing, see, let's suppose this is just one packet. Okay, let's suppose this is just one packet. Can you tell me what is the chance of losing it or reaching it to E? This is 1 upon 2 power 4, right? If this is just one packet, this is a chance. If there are multiple fragments, then the chance is actually decreasing. This is 1 upon by the 1 upon 16 probability, it will be reaching to E. Now by the 1 upon 256 probability, it will be reaching to E, right? Because if any of this is lost, then the whole fragment is lost. Okay, so the chance is actually increasing. So which means I will say here the fragmentation is increasing the likelihood or the chances, right? So it will increase it. Each fragment can be dropped independently of others, yet the package needs all the fragments to be reconstructed. So basically, if there's a fragmentation, there's a chance that you are basically making it more complicated in the sense that the packet may get lost with more probability. Because if any of the fragment is lost, the packet will get lost. Okay. Packet is lost. So basically, if there is only one fragment, then you will say that the one fragment will be traveling. Let's suppose these are the links. Okay, will be traveling these links with, I mean, if there is only one packet, then it will be surviving. Let's suppose this is P. It will be. Let's suppose this is a survival probability, which means the probability that it is any datagram is reaching successfully from here to here. This is the P probability. So what is the probability that only one reaches? P power 4. What is the probability two are reaching? P power 4 and P power 4, right? Which is P power 8. So, sorry. Like my question is that what is the probability that one is reaching if P is the probability? Let me do this question. This is actually some nice question, I think. So what I'm saying here is that if P is a probability, P is a probability of reaching from here to here. So probability of reaching or probability of success is P of one datagram. When there is no fragmentation, then what is the probability of success? Then A to D success fully reached is P power 3. Let's suppose there is a fragmentation with two fragments. Then what is the probability of success that both of the fragments reaches D? This is a nice question. Okay. What is the probability of success that both of the fragments reaches D? Probability of success of datagram that both of the fragment reaches D. What do you think? Just try to think about it. So what is the probability of success now? The probability of success will be the both are reaching. The first reaches, this is the probability of success, and the second also reaches. So basically, this is p power 6, right? So the success, the probability of success actually has decreased because the p is less than 1. So this number is actually lesser. So the probability of success of datagram now has been decreased with the fragmentation. When there is no fragmentation, only one is there. I just need to, it's just like that you have one kid or you have multiple kids, right? If there is only one baby, then you just need to take care of that only one baby. If there are multiple babies, you need to take care of multiple babies. So basically, obviously the tension will be more, right? So the probability of success of the datagram, if there is a fragmentation, then obviously there is a more tension. There can be any you can say the loss can be happen at any fragment. So that's why the probability of success will be decreasing, right? So this will decrease. Because we need both of the fragments to be reached. Now let's do this question. This is little tricky. Okay, this is little tricky question. Let's just try to solve this question. So what they're saying that suppose an IP datagram is fragmented into 10 fragments this time. Each has independent loss probability of 1%. What is the probability? Okay, so suppose that this is okay, one router to another router. There is only one link here. Now on this link, that it can get lost. Okay, so the probability of failure or probability of loss is 1%, which means 0.01. Now, what is the probability that now you are sending basically 10 fragments, okay? 10 fragments. Now they are saying what is the probability that datagram correctly reaches at the destination? Okay, don't worry about this this B part for now. I will come to this B part. So what is the probability that the datagram correctly reaches to the destination? Can you think about it? If there are 10 fragments, what do you want? You want 10 out of 10 to reach here, then only you will say the datagram correctly reached. What is the probability that only one will be reaching successfully? 0.99 of this is the probability of success, right? 0.99 is the probability of success. Only one of them is reaching 0.99. But will this just one of them will suffice? No. If you want the datagram to reach successfully, you want all of them to reach successfully, which means the first reach successfully and second reach successfully and the third fragment reach successfully and so on, right? So basically, this is 0.99 power 10, right? 0.99 power 10. So this is the probability that datagram will be reaching successfully if there are 10 fragments. Okay. Okay. So this is the part A. There is also the part B. By the way, suppose there is only one fragment, then what is the probability that it reaches successfully? 0.99 only, right? So that is the little more probability in this case. I mean, in always case, it will be more probability, but in this case, it will be like we can calculate. I don't know what it will be this number, but if you want 0.99 power 10, okay. So it is 0.904 something, right? So basically it is coming out to be 0.904. 0.904, right? And this is the probability that of success if there are 10 fragments. If there is just one fragment, then what is the probability of success? 0.99, which is quite higher, right? Than this. Okay. Now let's just see the second question that we have here. So this part B is actually little tricky. Let's just see what they are saying. So part A was saying if the datagram you are sending and there is only one fragment you are sending, right? There is only one fragment you are sending. Only one time you are sending. If you are sending only one time, then what is the probability of success? The probability of success is 0.99 power 10. But let's suppose you are sending 2 times. Okay, you are sending 2 times. Then what is the probability of success? That is what they are saying. Which means that if you are sending 2 times, then what you will say? You will say that let's suppose this is some router from here you are sending here. Now let's suppose you're sending all of these 10 fragments 2 times, one time and another time. Okay, let's suppose you're sending all of these 10 fragments 2 times. So what you will say here? You will say that what is the probability of success? One of them reach. Okay, just one of them. If you are sending any fragment 2 times, then what is the probability of success? Let's not worry about the 10 fragments. Let's suppose you are sending 2 fragments, just one fragment 2 times. What is the probability that that this one fragment, I mean, this is just a copy, okay? Just a copy of one fragment. Let's suppose there is only one packet. You are sending it here 2 times. What is the probability it reaches at least 1 time here? At least 1 time. At least 1 time. What is the probability? See what I'm saying. You're sending 2 packets. What is the probability that at least one of them reaches here? Okay. What is the probability here that at least one of them reaches? If for exactly one of them reaches, the probability is how much? 0.99. Right? What is the probability that at least one of them reaches? You can definitely have the cases like both reaches, right? Both reaches, or maybe something like that. I mean, this reaches, this doesn't reach. I mean, there could be the cases like both reaches, or the both reaches, this is the probability. Or what you can say, one of them reach, one of them doesn't reach, right? Just like this. So you can, or you can add all of this. I mean, this is one way, but there could be one nice way. What is that nice way? I mean, in these kind of questions, from the probability, you might be getting little practice from the discrete mathematics, that you need to think in the reverse way. If at least one of them, for the at least one of them, like probability of A or B, right? A or B. What you can say? This is 1 minus probability of A and B. Sorry. A or B complicate. The complement of this, which is nothing but 1 minus B. A complement and B complement, which means that first doesn't reach and the second doesn't reach. So what is the probability that at least one of them reach? So it means that first doesn't reach and the second doesn't reach. So what is the probability? The first doesn't reach and the second doesn't reach. First doesn't reach with what probability? 0.01. Second doesn't reach with what probability? 0.01. This is the probability that both doesn't reach. Okay. So at least one of them reach is this probability. 1 minus 0.01 into 0.01. So with this probability, at least one of them will be reaching. Yes. So yeah. So some people have given the correct answer. So with this probability, at least one of them will be reaching, right? Okay. Is this okay to everyone? So I want that at least one of them reach. So with this probability, at least one of them will be reaching. Now, this should happen 10 times. I mean, at least one of this copy reach, and at least one of them, the second pair reach, and at least one of them, the third pair reach, and so on. So this will be 1 minus 0.01 into 0.01 power 10. Isn't it? Is this okay to everyone? Yeah, which is actually equal to 0.9999 power 10. Okay. Something like this. So basically, I see this is just one pair. I want this to, for this one pair to successfully reach. So what I'm saying here, let me just tell you again. See, just think in just one terms. Okay. You are sending, let's suppose, only one packet. This one packet may reach with, let's suppose, with P probability. With P probability, it may reach. Now what I want, I'm sending 2 copies of the same packet. I want at least one of them to be reached, and that's the probability I want to calculate, because this is the definition of my success. Okay. So probability that at least one of the copy reaches. What is the probability at least one of the copy reaches? Is that 1 minus no copy reaches? What is the probability that no copy reaches? In terms of P, can you tell me? 1 minus, you can say that, okay, if this is the probability of success, probability of failure will be 1 minus P, right? Or maybe if you want, I can say that the probability of failure directly. So what is the probability of failure? 0.01, right? Which is given in the question. This is the failure probability. That the packet doesn't reach here. So if I want, see, this is just one packet. If I want that at least one of the copy reaches, what is the probability at least one of the copy reaches? 1 minus no copy reaches. See, probability of at least one of them, either A reaches or B reaches. This is same as 1 minus probability of A union B complement, which is nothing but 1 minus probability of A complement and B complement. If these are the independent transmissions, then 1 minus probability of A complement into probability of B complement. Okay. So what is the probability that first copy doesn't reach? 0.01. What is the probability second copy doesn't reach? 0.01. So with this probability, which is actually 0.9999, right? With this probability, what is happening? At least one of the copies reaching. Okay, for one pair. This is one pair. At least one of the copies reaching for one pair. And how many such pairs are there? 10 pairs. So basically, I'm retransmitting all the pairs, all the packets again. And my success will be that at least one of the copy from any of the pair reaches. Okay, so from this pair, any of the copy reaches. From this pair, any of the copy reaches, and so on. So for one pair to be successful, I say that one pair to be successful, this is 0.99. I want all the pairs to be successful. Then only my datagram will be successfully delivered, right? So this power time. Is this understood to everyone? This is the probability that my datagram will be successfully delivered if I'm sending them twice. If I'm sending all the fragments twice. If I'm sending all the fragments once, then what is the probability my datagram is successfully reaching? This is the probability, right? See, if I'm sending them once, then one will be reaching with this probability, second also reach, third also reach, and so on, right? Now there is no concept of pairing. Here I want this pair to be successful. Pair to be successful means at least one of them reaches, which means with this probability, at least one of them reaches, which means this is one pair reaches. For this, I mean, the pair successful is this probability. You just need to power time, just like here. Here, this is not the pair, this is just for one. Is this understood to everyone? Okay. So you can try any other method and then you can check whether your method is matching the same answer or not. So I hope you understood that what I'm trying to say is that if this is A, this is B, then if I'm transmitting only one fragment, okay? Only one fragment. Let's suppose these are the 10 fragments. Then when will I say my datagram is basically successfully reached here? Then all of the 10 reaches. This is 0.99 is the success probability. So all of the 10 reaches, right? Which means 0.99 over 10. With this probability, I will say that all of the 10 will be reaching, which means my datagram transmission is successful. Okay, probability datagram is successful transmitted. If I am sending just one time, but let's assume the case where I am sending every packet 2 times. Okay, every packet 2 times. So in that case, what will happen? That was my question, right? Is it too hard to understand? Or you people have made a mind that okay, जब तक easy नहीं होगा तब तक मतलब solve ही नहीं करेंगे. Is this very hard to understand? Let's suppose you are sending two copies, right? Two copies, which means one pair. Now this time I want the pair to be successful. Okay, every pair to be successful. So for one pair to be successful, probability for one pair to be successful is 1 minus, I mean, we have calculated it 0.01. For one pair to be successful, the probability is coming out to be 0.4 times 9. Okay, for one pair to be successful. I want all the pairs to be successful, right? That's all. I mean, just like above. And then I will say the probability that datagram is successful. So now you tell me which one is the greater number, 0.99 power 10 or 0.4 times 9 power 10. This is 0.904, right? And 4 times 9. This is 0.999. I mean, this is quite high, right? And obviously it needs to be high because you are transmitting twice. So at least you expect that, okay, your probability of reaching the datagram successfully should be more, right? Let's just see the answer. 0.4 times 9, 0.2 times 9, right? So this number is approximately this number is approximately this. Was that tricky? Yeah, question was tricky, I agree. But now, is this clear? Okay. So, see, I already gave you the disclaimer that this is a tricky question. But now I hope the question is clear. Okay. So let's now do this question. This question I have taken from CMU. Okay, link is not here, but yeah, this question I have taken from CMU. Okay. So what they're saying that there is 2 MTU which is given, which is 9,000, 9,000. Okay. 2 MTUs are given to you. A2B link and E2F link. This E2F is 9,000 and A2B is also 9,000. Now they are saying that node A sends an IP packet of size 2604 bytes. Okay. So A is sending 2604 bytes to F. The packet undergoes the fragmentation in this network, and F receives 3 fragments of size. So this is 1500 bytes that F is receiving. Okay. F receives 1500 bytes, 572 bytes, and 572 bytes. So they are saying that you are sending 2604 bytes here, and then you are receiving at F this much length. Not necessarily in that order. The sizes, all the sizes includes the sizes of the both IP header and the payload. Okay. Now, what they're asking is that suggest possible MTU values for BC, for this link, this link, this link, and this link. What are the possible MTU values for this link? So see, 2604 you are sending, right? Which means what is the without IP header? 2604 minus 20. What it will be? If you subtract 20, you will be getting 82584, right? So 2584 is basically you are sending. Okay. So without the IP header, you are sending 2584. So you need to split this 2584. Now they are saying that finally you got one with 1500 bytes, 572 and 572, which means 1480, and then 552 bytes, and then 552 bytes. I mean, you got 3 fragments with something like this. Okay. Now they are saying that which of the following MTUs are possible? Tell me for this BC link. See, you are fragmenting something. I mean, they are saying 576 or 1500. They are just asking the MTU, which is either 576 or 1500. So you are sending something which is basically having one of the fragment is having 1480, or I mean, it must pass through the 1500 MTU. So can D be the answer? If all the links here are 576, can the 1480 is even possible? No, right? So D is definitely not the answer, which means if all are 576, 576, this is 576, 576, 576, 576, then you cannot get a fragment of 1480. So that is for sure. Now tell me, can this and this, can these two link of 576? If you're getting one of them is 480, 1480, can both of this is 576? What do you think? No, right? Why? Because if both of them are 576, then it must have split into 576. So one thing is for sure, to get 1480 here, one of them, I mean, both cannot be 576. One of them could be, I mean, must be 1500, right? Don't worry about this, this 80. You can consider 1500, 572, 570. You can consider the total length. Okay. Here, the calculation won't be like that we need to consider without total length. So basically, let's only talk about in terms of total length. So if you're getting 1500 here, okay, as a total length, then it must mean, if you're getting 1500 here, then it must mean that both cannot be this 576 or something, right? So here you are sending 2584, right? These are the total bytes you are sending. So if you're sending these total bytes, you are saying that these are, I mean, as a total length, you are receiving 3 packets with 572, 572, and 1500 bytes. Okay. If you do not include the header, then you are receiving something like this, which is fine. I mean, that is okay. But I'm also writing the total length. If you are receiving some of the packet with 1500 as total length, then is this possible that D is the answer? That everything is 576? Just tell me. Can D be the answer possible? No, right? No. If everything is 576, then obviously you cannot receive this 1500. Okay. Now, if you want to receive some packet as 1500, then one thing is for sure that one of the path must be 1500. I mean, everything in one of the path must be 1500. Then only one packet will be delivered as 1500, which means this, if this is 1500, then this must be 1500, something like this. I mean, one of the path must be 1500. It cannot be the case that let's suppose if these are the MTU which is given, the 1500, 1500, 576, 576. With these kind of configuration, can you ever get this 1500 finally? No, right? Because it won't be able to travel. I mean, the bottleneck is 576 still. So with this kind of configuration also not possible, which means if BC and BD, BC and BD is 1500 and CE and D is 576, then also it is not possible, right? So C is also incorrect. C is also false. Understood? Why C is false? Because in this case, the bottleneck is still 576 and you cannot have 1500 at the end. So that's why C is also false. Let's just see if A and B both are correct or just one of them is correct. Since this is MSQ question, so let's just see if both are correct or only one of them is correct. Okay. So what about the option A? Which means if you have 1500 here, C is also 1500. This is 576. This is 576. With this option, is it possible to get 572, 572 and 1500? So what you might be doing, you will be dividing. See, anyway, if this is 576, then anyway, the maximum length that it can carry is 572 because of the multiple of 8. Okay. Because of the multiple of 8, what you will be doing, this is basically 556 and you can't carry 556. So that's why you need to carry 552, which will eventually be the total length of 572. Okay. So if you are having something like this, then can you receive these packets? What do you think? So yes, this B might be fragmenting in such a way that one of the packet is going 1500 is going here. This 1480 packet will be going here. And this 552 may go here, right? So with this A 1500, the C is 1500, it's 576, 576. If you have something like this, then definitely this kind of arrival is possible, right? So with this A, this kind of arrival is possible. What about with this B? Is this B correct? Which means if 3 links are 1500, BD is also 1500, right? This is also 1500. Then what you will do? You will say that, okay, initially both are, you are sending 1480, I mean, you will be sending one of them as 1480 and another one will be 2584 minus 1480, right? 1104. So you will be at B. At B, you will be dividing 2584 into this. 2584 is including header or not? Yeah, without including. Okay. So you will be dividing into 1480 and 1104, right? At B, you will be dividing something like this. So if this is a configuration, then 1480 and 1104. Then 1480 will be traveled. Okay. Let's suppose that you are sending it here. I mean, I'm just checking the possibility that with this, can you get these three? So with this, you will be dividing one of them as 1480, another one as 1104. Is this fine? Now I'm saying, let's suppose this 1480 is sending from here. Okay. I'm just checking the possibility. If you send it from here, it will be delivered successfully. And 1480 you are receiving. What about 1104? If you send 1104, then because of this 576, it will be again be splitted. It will be splitted into two parts. One of them will be, since this is MTU, so 556, which is actually not multiple of 8, so 552, right? So 552 here and 552 here, right? So I think yes. So if you do this kind of configuration, then also it is yes. So B is also possible. Okay. So A and B are possible and C and D are not possible. So that was just one easy question that they are trying to ask, that what are the possible values such that you get these as a final result. Okay. So one thing is to note here is that at this router B, you are splitting in such a way, it is also possible. Let's suppose this is 1500 and let's suppose this is 576. It is also possible to split one packet into two parts which are on the different MTU. Okay. It's not like that, okay, for the same MTU you need to divide. This router can take the decision to divide such that one of the packet it is sending here, one of the packet it is sending here. So what is the final answer here? The final answer is A and B. Okay. Yeah. Thank you, Saurabh. So Saurabh is saying nice problem. So thanks for that. So I think these are the only possible variations that we can have. Okay. So one of the question we have done from the Stanford, that Stanford question was related to probability. That was the only different variation that we can have here. And I think all the possible variations we have covered, right? Okay. So thank you everyone. That is all for today. So we have solved 15 questions in this particular session. Okay. Thank you everyone. Take care. Bye bye.